All right, so I think we'll go ahead and get started. This is a tutorial session called Running and Analyzing Machine Learning Experiments in the Cloud with AWS, Python, and R. The session does run until about 5. I have the agenda, so in case anybody wants to jump in and out. So just a quick overview on who I am. My name is Aaron Richter. I received my PhD from Florida Atlantic University, actually under Dr. Kashkaftar, the chair of the conference. And I'm also a data scientist at Modernizing Medicine. It's an electronic health record company, actually just down the street. And I've been there for about 5.5 years as a data scientist, doing a lot of data engineering work as well. And this is where a lot of the experience working with the cloud comes in, because it's a fully cloud-based platform. So we use Amazon a lot for different things. And then I used some of that to actually run my machine learning experiments for my own research. So I've been using the cloud a lot over the last few years, so we'll jump into that. So just real quick, before we get started, just so I know kind of what the audience kind of looks like here and what everybody's looking to learn. Who here is familiar with like Python for data science and machine learning, scikit-learn? You kind of use that on your day-to-day research stuff? Okay, good, so most of the room. What about on the R side? So tidyverse, dplyr, ggplot, R. Okay, still a good amount, maybe a little bit less. Shiny, anybody with Shiny dashboards? Okay, we got some. And then the last question is, what about like cloud, AWS, GCP, Azure? Okay, so that's the least amount of hands, so that's good. That's what this talk is about. So I'm not going to be introducing all of the Python, scikit-learn, everything technologies, but we will be talking about the cloud a lot. So the goal of this and this tutorial is to kind of enable machine learning experimentation on the cloud. So the focus is doing stuff on the cloud. Of course, we're going to have to use some Python, some scikit-learn, some R to get there. But it's really for training and evaluation. There's a lot of whole other world about deploying machine learning models, and that's a big part of a kind of industry using machine learning and some research as well. And there's a lot of technologies there that's still kind of being developed. This particularly is if you're in an academic setting, you just have some algorithms that you're building, you want to try out, and you need to do a lot of stuff, and you kind of want to do it on the cloud. That's what this is for. So out of scope for this talk is really a background on data processing. I would assume that a lot of people here have done that stuff. Not a whole lot on the machine learning theory. We're just going to use a couple models. I'm not really going to explain them. And then we're going to leave out model deployment or serving predictions out of this. So the goal is really training a bunch of models and evaluating them. Here's the technologies we're going to cover. It's the cloud platform we're going to use is Amazon Web Services, and I will introduce that in just a bit. But as far as Python, if you're not super familiar with all these technologies on here, it's okay. I'll walk through a couple different pieces, and even if you use this stuff on a day-to-day basis, sometimes it's good just to see somebody else doing it. Maybe you'll learn a new method, or you'll learn some new approach to doing something in any of these things. But this is just a high level of what we're going to go over. So for development environments, we're going to do, we have to do some things in the command line here and there. Won't do too much, but it's going to be heavy on the Jupyter side. So we'll use Jupyter notebooks for the Python and pandas for the data processing, maybe a little bit of NumPy as well. But then scikit-learn on the machine learning side. We'll train a few models there. And then we're going to do keras a little bit. I'm not going to focus too much on that. I just kind of want to show you that it's possible to do these things. But I'm not really an expert on deep learning and keras and TensorFlow, but I at least want to just show that. On the R side, and this is just a consequence of how I ended up doing my research, I found that the scikit-learn platform and the Python ecosystem was really good for dealing with big data, processing it, doing the machine learning. And then I still did all of my results analysis with R inside of RStudio, just because it's a little bit of a better environment to do data processing on that smaller data, to make like nice HTML files, or to make a dashboard, and all the statistical stuff that comes in R. It's very handy from that perspective, and I found that Python was a little clunky using that. So this is heavily drawn from my own experience, but I hope it can help yours. So as far as R, the R code isn't going to be too crazy. It'll be tidyverse stuff, so some dplyr just to download some data, and then we're going to build a Shiny app. So the goal at the end of this is really so you can put together pieces where you can be training a series of models on the cloud. Maybe it has to run for a few days, few weeks, and then you can set up a dashboard that'll also be monitoring that experiment and seeing how the experiments are running, and kind of where your progress is, what the results are, so that way you don't have to wait for your experiment to be finished before you actually can see some of the results. And then on the Amazon Web Services side, I'm going to go through a bunch of different services, S3, EC2, and SageMaker, and I'll explain what those are in just a minute. But that is going to be on Amazon. I think a lot of the concepts will be able to translate to any other cloud environment. So like Microsoft Azure or Google's cloud platform, GCP. You can probably translate some of the concepts. I have not used any of those other cloud platforms, so I can't really speak exactly to those. But the concept should be relatively the same. So that's pretty much it. So the schedule, I have the schedule posted on the door, on the inside and the outside, just in case you kind of already know the cloud and you want to just come back for the ML part or for the Shiny part or whatever. But yeah, feel free to take a picture. So we have the room until 5. And the beginning part is the only part where I'm really just going to be talking to you. The rest of it is I'll be on the computer actually doing some things. We're not probably going to be able to do like a hands-on like together type thing. I know I only see a few laptops in the room anyway, but with the cloud it's like you got to set it up, you got to pay for all the stuff and get all this, a lot of like overhead involved. So I am recording the session, so if you want to go back and do this yourself, you can find the link and just kind of shoot me an email or follow me on Twitter or something. You'll be able to see kind of the video after. I'll try to get it up like tomorrow or as soon as I can. So as far as what we're going to go through is now until the next maybe 20 minutes, we'll just be talking about the cloud and kind of what it is, what are the different services, some considerations about all those different things. And then I'll walk through a little bit actually setting up the AWS environment for running machine learning. So the minimum viable thing that we're going to do in this first section is actually just setting up AWS, launching a Jupyter notebook, running on an instance. So that's going to be kind of just the hello world of what we're doing. And then after the break, we'll actually dive into doing some real stuff. So examples we're going to use is from some Medicare data, and I'll introduce the problem when we get there. But once the environment's set up, then we'll do some machine learning with the Jupyter notebook and kind of kick off some job that'll be running for a couple hours. And then while that's running, we'll go ahead and work on building the dashboard in Shiny, first doing some analysis with R, and then launching the dashboard, and even actually deploying the dashboard as well to a service called shinyapps.io, where it would be accessible to the public web. After that, if anybody is still here after all of that, I'm going to describe a little bit more of what it takes to do some really, really heavy experimentation. The first part of the session is to really get you from 0 to running stuff in the cloud, analyzing stuff in the cloud. But the bottom part, this last section that I'm scheduled for 4:15, I'll actually go through a little bit, a few of the experiments that I did for my own research. Actually, even one of them was a paper that I presented at this conference. And I won't really be running stuff live because I basically had to build a lot of code around like launching a instance, running the experiment, saving the file somewhere, and all that stuff. But I'll just give like a quick walkthrough and just some gotchas and things here and there, because this stuff can get a little bit kind of just weird, especially if you're not familiar with the cloud or any sort of DevOps or machine hosting type of scenarios. So there's some few things you have to consider when you're doing this stuff. So I'll try to point out little tips here and there as I go along. And feel free to interrupt me if there's any questions, because this is kind of like, this is for everybody here to learn. And I have this kind of initial schedule. We may go faster, it may go slower, so we'll kind of just see how it goes, and I'll adjust the break times if necessary. I know the other sessions have a break around 2:30, so if necessary, we can take a break around then if everybody wants to get coffee and everything. So, but we'll see how it goes. Any questions before I kind of just dive into the first section, which is introducing the cloud?
Could you just put your email address up again? So we
Yeah,
can
absolutely.
send you
There it is. So that's my Twitter and my email address, if anybody wants it. It's the same.
Thank you.
That string, you can find me on anywhere in the internet. I got lucky with a unique name. So. Okay, let's do it. Okay, so this is what we're all here for, right? what is the cloud? So we're going to go into just introducing the cloud itself, and then really a lot of this explanation is going to be in the context of AWS. Like I said, you can translate a lot of these concepts over to the other ones, but it's kind of all kind of the same idea here. So from the very simplest definition, this is really all you need to know about the cloud. So if you can't read it, it's kind of small, but basically it says there is no cloud, it's just somebody else's computer. So that is essentially what the cloud is. And of course it's been very popular over the recent maybe 10, 15 years because there's now infrastructure to manage what is this cloud. But if you think about it, technically you've had the cloud around since the beginning of the internet. Because when you open a web page, it's running on somebody else's computer and they're serving the information back to you. Technically, that is what the cloud is. It's basically offloading any compute resources to somebody else. So rather than, from a business context or even from an academic context, rather than having a big cluster of machines somewhere, you have to hire 10 people to manage them, make sure they're always on, make sure they're not overheating, make sure you're upgrading the software, all those different things. Now you can just, you're a single person, as long as you're paying for it, you can just launch a machine now that's being managed by some other company like Amazon or Microsoft or Google. So what the cloud does and what really Amazon, and the history of this is that Amazon had this big network, right? Like to serve all of the things that they needed to do, they had a whole bunch of servers all sitting around everywhere. They had this gigantic team of DevOps engineers all managing the servers, making sure everything's running. And so the idea there was, well, we have all these servers sitting around, and sometimes they're idle. Why don't we just rent it out to other people and take advantage of it? There's already a big expensive box here. It's not doing anything. Let's just make money off it while it's sitting there. So that's really how the cloud was born and how a lot of this took off, and that's why Amazon Web Services is at the top, because they kind of did that. They built this infrastructure first, and now they basically control all of the internet. So I don't know if anybody remembers a couple years ago, there was a time where Amazon S3, which is the file storage service, it actually went down, and on the East Coast, and half the internet just disappeared because everybody was dependent on files inside of S3. And you'll see why, because it's really easy to use, and it's great. So they claim 99.99999% uptime, but of course that 0.00001 is always going to happen, and then we're all stuck. So that's really what the cloud is. It's somebody else's computer. And all of this work to do stuff on the cloud is you have to pay for it. You have to make sure that, okay, if you have 30 people on the same machine or set of servers, you got to make sure that all their data is separated accordingly. You got to make sure everything is up, all that stuff. But for people like us, makes our lives a whole lot easier, because now you don't have, especially if you're in an institution where there's really, really limited resources and limited staff to host servers for you, now you can kind of just do it yourself. And there's some academic discounts and stuff, I'm sure, in all of them. So I think I said a lot of this stuff, but basically, why do we use the cloud? So what I'm trying to convince you and show you how to do is, rather than doing the computing on your laptop, my laptop here has 16 gigs of RAM, I can only fit a data set that's less than 16 gigs of RAM on my laptop. And then if I want to do stuff with it, it's just going to blow it up, right? So the point of the cloud is you need computing that is larger than what you have available or readily available for you. So these are 3 big points of it. I'll start first with the scalability, though, and this is the reason. Is some of these data sets that I was working on in my research, the single CSV file was 200 gigs. Right? You can't even do anything with that on your computer. How do I even download it to my computer? Might not even have that much storage, right? So now you can actually operate with that file, because now I can launch some machine that has 500 gigs of RAM on it, and I'm just paying per hour or per minute to use that. And I can dump it on some scalable file storage now that it's always available for me. So that's the biggest thing, and for the context of what we're doing in the machine learning research is now I can launch a machine. Let's say I'm training a deep learning model. I need a GPU. I don't want to spend a bunch of money on a GPU. Now I can just rent that. Or I'm doing some sort of ensemble model that needs a lot of CPUs going on, so I can launch some machine that has 64 CPUs on it, which is a lot better than, I have a good one, but it's 16 on mine, right? So that's the kind of goal. You can scale out, and you don't just launch one machine at a time. You can launch 30 machines at a time. You're going to pay for it, but maybe you have 30 different models you want to try. You can do them all at once now instead of waiting 2 weeks. Some of my experiments, I had I think one of them, it counted for hundreds of hours of CPU compute, but I was able to do the whole thing in a few days because I can launch a bunch of machines at the same time. The ease of use. this is a good point. It's like, okay, well, let's say I did need a machine with 500 gigs of RAM. I don't want to go somewhere and buy this machine now, use it for a couple months, and then I'm done with it. Now you just spent all that money on that machine. Here, you can just rent it for a little bit. You don't have to deal with setting it up. You don't have to deal with something if it breaks. You don't have to deal with setting up the file system, installing all your packages, making sure dependencies are good. Here, you just launch a machine, and you can say, launch this machine, I want to do machine learning on it, and it needs scikit-learn and pandas and keras and everything, and then it'll come configured, boom, you can just get started and get going. And the one thing is also cost. Cost is something that you have to be careful with, but it's also something that's very advantageous because you pay for usage. You don't just pay for the machine that's going to be obsolete in 6 months once the new thing comes out. You pay hourly, and on Amazon's case, you actually pay by the second, I believe. So you can always get the newest hardware, and you're just paying by the second whenever you use it. So for context, I spent less than $10 preparing for this particular tutorial. So I launched big machines with like 70 gigs of RAM and a bunch of CPUs. And of course, it took a long time to actually get everything together. And I probably, in reality, I didn't have time to check my actual bill, but I probably spent like $2 or $3 just to prepare this whole thing. So today, for the 4 hours that I'm going to be running the machine, I'll probably end up paying like $1. So it's really helpful. And especially if you have a grant or something, you can now spin up a whole bunch of machines instead of just buying one. To illustrate this kind of cost thing a little bit more, here is one of the GPUs that people would use for deep learning. And this is a NVIDIA Tesla V100 with 16 gigs of video RAM. Some of them have like 64, 32 gigs of video RAM. I just took the smallest one, right? And you can see here, I don't know if anybody can see that, it's kind of small, but this is a screenshot I took from Amazon just a couple days ago. Amazon, the actual Amazon, not the web services. And $5,834. But there's free shipping, so you know. So if you wanted to do deep learning and you needed a GPU and you wanted like the latest and a good one, you'd have to drop $5,000 just for the GPU. Then you have to pay for a machine that can actually host this GPU. So of course you would want to get a really good machine. You're not going to be spending another $2,000, $3,000, $5,000 just for the box, the motherboard, CPU, RAM, all that stuff. And then it's only in one place. You have to come to the lab to use it. Well, I guess you could log in remotely, and you know your lab floods or something happens, the AC goes down. Yeah, you have to deal with all these physical factors for this particular machine. Not to mention what always happens in academia is a professor gets a grant, they buy a bunch of machines, and then they don't get a grant again for another 5 years, and now you're stuck using this old machinery. So, yes?
So I think in our regular laptop or computer, we always have a graphical card. Can that be used as a GPU when you do deep learning?
It depends on what machine you have. So most Macs actually have AMD graphics cards, which don't really work well with deep learning because NVIDIA basically cornered the market there on deep learning. So all of the software and stuff that optimizes deep learning on GPUs, it has to be NVIDIA cards. So if you're on a Mac, you can do stuff, but it'd probably just be on the CPU. And even if you do it on the GPU, it's not going to be super optimized. But these GPUs are way, way, way more performant than anything that you could get on a laptop. If you got like a gaming PC with an NVIDIA GPU, you can actually get something decent. And like if you need a laptop anyway, you can go ahead and get that one, and that's good for like prototyping, for training stuff on it. But then eventually, if you really do have a large amount of data and you're really doing a lot, you might hit a ceiling at some point.
I see. So even if, for example, my Mac has a GPU card, when I install some software, I can only choose the non-GPU version.
Probably. I can't say for sure because I haven't done it myself, but I know CUDA is the big software that optimizes deep learning on GPUs, and that's only compatible with NVIDIA. So all Macs have AMDs. So it's going to be even if it runs on the GPU, it's going to be very not optimized in that context. Yeah.
Thank you.
No problem. So we're going to switch now to an Amazon Web Services page. And I know the text is kind of small, but this is a screenshot from, we're going to go through this in just a second, but this is a screenshot from one of the web services instances. So these are machines that you could launch in the cloud to actually use. This is the same GPUs. That's why I took this example. This is the Tesla V100. You can launch a machine with one of these GPUs with 64 gigs of RAM, 16 gigs of video RAM, the same thing, and then 8 CPUs. You can even launch one that has 4. So that's already $20,000, right? If you just want to buy 4 of those GPUs. And then they have even like bigger ones and fancier ones. I just wanted to draw this parallel. So if we look at the pricing over here, for that same instance, the P3.2x large, we're going to go into that, what that means, is $3 per hour. So if you're only doing like one project that needs a GPU, you only need it for a couple months, you're not going to be, first of all, you're not going to be running it 24/7, right? You're going to be running it during the day at first when you're developing, you're trying your model, whatever. Once you get your code ready, you're going to let it run for a few days. And then that's it. So $3 per hour is a whole lot cheaper than $5,000. So of course, if you do the math, to get the same value out of that GPU, you'd probably have to use it like, I can't do the math in my head, but you have to use it a lot. And it had to be on 24/7, like at least 2/3 of the year to get to that $5,000 cost. So if you are like a super intense deep learning shop and you're really doing crazy stuff, then yeah, maybe you should invest in a GPU. But if you're kind of just a tourist, or you're kind of looking to see if it's applicable for your research, or you just want to try some fast AI new stuff or some new Kera stuff just to learn it for yourself, it's really easy to do that. And I will say too that there's other services out there for you to run stuff in the cloud, especially with deep learning. There are some services that make things even easier than what I'm about to show you now. But Amazon is nice because it's very flexible. You basically get your own machine to do what you want with. And I'll talk about that a little bit more too. And this is the regular on-demand pricing. They have some discounted pricing, which I'll explain kind of what happens, but you can get a spot instance, which gives you discounted pricing, and there's some consequences to using it, but that's even just under $1 per hour. So way, way, way cheaper than $5,000, even cheaper than the $3 per hour. I'll explain what spot is in just a second. So we'll dive into that. Let me drink water.
Excuse me, are you talking about lapsed hours there? Or is that CPU hours? Or
it's a lapse time. So you essentially turn on the machine. As long as the machine is on, you're paying for it.
I see. And I assume you can freeze it if you want to stop and go away and come back to it.
Exactly. You can freeze it, and essentially what you would do is you would stop the instance,
Right.
and it saves your storage. So it has these storage disks, and you pay like pennies per gig for those storage. But then if you stop your instance, you're not paying the $3 an hour anymore. But then if you want to turn it back on, you just spin it right back up, and then you get your disks back, and all your data is still there.
Beautiful.
So once you pick a configuration, that will stay the same way, right? When you run.
Yes, you can do that. And I'll show some examples as we kind of dive into this, but there's a ton of different types of machines that you get. If you're doing CPU stuff, or you need memory stuff, or you need GPU stuff, there's all kinds of different things, and we'll walk through all of that stuff just a second. So like I showed at the technologies slide, as far as AWS services that we're going to look into, the foundation is going to be S3 because that's the storage layer. EC2 is what actually lets you launch machines. And then SageMaker is actually Amazon's machine learning platform, which is built on top of the other two services. So that's just 3 products that Amazon has. Amazon has a ton of products. So especially in a business context, in an environment where maybe you don't have a problem that's like cutting edge that you really need some new research on, maybe you just have a database somewhere and you can train a logistic regression model on it, and then you want to deploy it somewhere in an app. Amazon has services all over the place to cover everything. So I just clicked on the compute thing. If you go on this website, there's analytics, AR, blockchain, business application, databases, like all kinds of other stuff. So anything that you could think of that you would have to manage yourself, Amazon has some other service there for you. So of course they're charging for it, right? The base layer is just this compute. So you could do everything that you want to, just getting a machine, renting it. Let's say I'm going to put a database on it. And then you can pay for that machine hourly, and there's a database. But then you still have to manage the database. What if a connection goes down? What if the service goes down? What if somebody blows it up? You still have to go in and manage that. Amazon has other services like RDS, which is a relational database service, which they basically manage the server for you. So it's almost like a serverless type interface. Is you just say, I want this database, it's going to scale to how many users it's getting, and then you're just paying for usage there. And on the slides, I'll share the slides and the video and everything afterwards too, so you'll be able to click on a lot of these links. Okay, first up is the storage layer. So this is S3. So S3, if you're not familiar with, so I actually never really realized what it stood for, is Simple Storage Service. So this is kind of the backbone, and this is where it helps you start thinking about how the cloud is really, really helpful. So essentially what S3 is infinite, always up data store. So of course you kind of have to put those in quotes because in practice it feels like it is infinite and it feels like it's always up, but you know, there is bounds to everything, right? But Amazon just managed a whole bunch of disks somewhere and they have all this code and all these engineers optimized to serving the storage layer. So the really good pros to S3 is that it's actually very cheap to store data. It's free to transfer data into it, of course, right? Because they want you to put data in. And then it's cheap to transfer it between AWS services. And you'll see what I mean by transfer between services. But essentially, the way you can think about S3 is it's not quite a file system like you could think of if you're familiar with like NTFS or FAT or any kind of file system like that. What it is an object storage or a blob storage. So any file that you save to S3 is just a single file by itself. So it's similar to how Google Drive works. Let's say I want to save a CSV file to S3. I run a command, it uploads it to S3. There's actually technically no real directories, and you can see here, this is the path, this is what a URL to an object in S3 would look like. There's a bucket, which everybody creates, which is essentially, you can think about it, it's kind of like a domain name like you would have on a website. It's your unique name where you're storing your stuff. So similar to like C:, or like amount you would have on Linux. There's your bucket. And then you basically have a string afterwards. It's actually not called a prefix, it's called a key. I'm just realizing it's called key. Essentially is the name of your file. So in S3, there technically are not directories. So if you put a slash in your file name, it's actually still one big file name, but it's not actually a directory. But then they do stuff in there to treat it like a directory. So it's kind of weird. And you'll see as you work with S3 more, there's no way to copy a folder. What you have to do is copy every single object after a specific prefix. So like if I say, if I have my S3 bucket, it's S3/Aaron/files. If I have 30 files under that slash, you can't just move that directory. There's no operation for that. What you would have to do is copy every single one of those files into another place. But there's some code and there's packages out there that optimize for that. But that's just to think about the concept. But that's pretty much it. You can treat it like it's a hard drive, right? Throw data on there, you get data off. And it's pretty fast. And probably almost at least half the internet has something on S3 and is depending on files on S3. One thing to consider is that you do have to pay for data transfer costs. So when you transfer something from Amazon S3, and let's say you launch a machine where you're going to do a machine learning experiment, you need to grab data off of S3 onto that machine, you're going to pay a little bit. But it's very, very minimal. You really don't notice those costs. It's like fractions of a penny. But they charge you when you download data out of Amazon, out of the Amazon ecosystem, which essentially means to the public web. So that can be your laptop. That can be if you're hosting some website, a user downloads something from your website that's actually off of S3, you're paying for all those costs. And right now, it fluctuates a little bit, but right now it's 9 cents a gig. So when you're downloading something, one time I remember I had like a really big file that I had to download off of my S3 bucket onto my computer, and for that single download I actually paid $7. So that's something to consider when you have a lot of data in S3. But if you're operating just within S3, it's fine. A lot of the times, let's say there's some big file that somebody has on a website and you want to download it, you could actually run a command that would just download that straight to an EC2 instance, then you copy from that EC2 instance to the S3 bucket, and then from there you're just going between Amazon services and you don't have to worry about the cost. I mean, most of the time you wouldn't be doing anything with a 200 gig file on your computer anyway, so something to consider.
You need a lot of data.
Yeah.
Let's say it was on Dropbox.
Sure.
You could read it in from Dropbox to this and then do whatever manipulation you want and then throw it away and it wouldn't actually cost anything other than the time to do that.
The time, and then there's very minimal cost in transferring between Amazon services, but it's really negligible. Okay. So as long as you're only going in and staying within Amazon and not going back out, it's really affordable. If you wanted to put all that stuff back to Dropbox, that's when it would get expensive.
They get killed.
Yeah, but with S3, you could then just put it on an S3 bucket and then give people access to that S3 bucket. You don't even need Dropbox anymore.
Right.
Any questions on S3 storage layer?
How is it secured?
They have all kinds of stuff. It is very secured. I mean, I work in a healthcare company, and we have all of our
Right.
stuff inside of Amazon. So when you're in a healthcare company, you have to have special agreements with them. You have to be in a special, like, kind of single-tenant hardware, and they have, like, encryption in every place. I'm sure it's and then there are options as well for encryption. There's options for encryption. There's also options for versioning. So one time I accidentally deleted a bunch of data, but luckily they kept versions up, so I just restored the old versions. So they really make it hard to lose your data and hard for your data to be stolen. But if you can accidentally make your data public. So that's something that you really have to consider with these things. I'm going to show you, I'm working with an S3 bucket that's public to the internet because I want everybody here to be able to use data from my bucket. But if I ended up putting some private file I didn't want on there, it would now be open to the internet.
So it is HIPAA compliant.
Yeah, it can be HIPAA compliant, and I'm sure all the other PCI, whatever all the other places need for certifications. Yeah.
Thank you.
Sure. Okay, next up is EC2. So another acronym stands for Elastic Compute Cloud. So it's exactly what it sounds like. But you can think about when you think of an EC2, and the word that they use is instance. So an instance is exactly a computer sitting somewhere around the world. And when you launch an instance, Amazon is granting you access to do computing on that instance. And it's just like any other machine. So if you've worked with servers before at your own institutions, it's the same operation. You can SSH onto it, you do a bunch of stuff, you can have multiple users. It's just a regular machine. They have Windows, Linux, all that stuff. But I mean, Windows really? Sorry, I'm a Mac and Linux guy. So the price depends on the instance, right? It depends on what you're doing. I'll kind of dive in here and we can look at it a little bit just to poke around. Let's look. So you can also launch from pre-configured images, which is what we're going to do. We're going to launch a machine image that has all the deep learning, all the machine learning packages pre-installed. You don't even have to install anything. And then I'll show you the difference in the pricings. So let me just jump in here real fast. So hopefully the internet is good. Okay, so if you look here on the left, they have all different types of instances. General purpose, compute optimized, memory, all that stuff. So if you ever need to know kind of what kind of machinery is possible on Amazon, you just go to this page. And it's just, if you literally just Google Amazon instance types, it'll come right up. So they have some general purpose ones. The really exciting ones for what we would want to do is like some compute optimized. So all of the instances have these kind of names, and you'll see it right here. So it's all usually a letter, number, dot, large, x large, 2x large, 16x large, that kind of stuff. So you can see all the different types of compute optimized instances. You can go as small as just 2 CPUs, 4 gigs. But if you want to go really crazy, you can get 96 CPUs, 192 gigs of RAM, and some of the bandwidth. And I'll explain kind of how the storage works a little bit later on. But this EBS storage essentially is like another kind of expandable storage. It's not like one single hard drive. You can have variable sizes of the storage. But let's see. I think accelerated computing, this is where the fun stuff is. Yeah. So accelerated computing is where you're going to get the GPU instances. So the ones that I'm probably not going to launch one today. I'll just show you a Jupyter notebook that was run on one. But this is where I took that screenshot. See this V100 GPUs? I showed this to you already, right? So you can see you get a GPU. You can even get something with 8 V100s, 96 CPUs, 700 gigs of RAM. You're going to pay a lot for that one, but you can get it. They're storage optimized, memory optimized. So it really depends on what kind of thing you're doing. If you have a ginormous data set and you're really not doing anything super complex with it, maybe you're just doing like a logistic regression or any kind of single core machine learning model, you'd probably launch a memory optimized instance. If you're doing an ensemble model like a random forest, XGBoost, I'd recommend the CPU optimized, the compute optimized, because those are very easily parallelizable with scikit-learn, and it'll run on all your CPUs. And we'll see that. I'm going to show an example with random forest. So if we go here to pricing, we can see, I'll open it in a new tab so we can go back and forth. If you go to pricing, there's really a few different types of pricing, but the two main ones you have to consider is on-demand and spot. So on-demand is basically just you want a machine and you want it guaranteed up. I said I want a machine, it's always up all the time, and then you pay for that. What spot is, it's kind of the concept where Amazon has some machines sitting around that aren't being used. They offer you discounted rates, but the catch is that your machine can disappear at any time. So they can send a signal to your machine that says, in 2 minutes, you're going down. So then either your code has to respond, or you have to make sure that all your data is saved in S3. So the concept of S3 actually, and this is where it is really, really nice, is S3 does not depend on any instances being up. So your storage is there 100% all the time. You copy data between S3 and these instances. So let's say I'm running something on a Spot instance, and I just checkpoint my model, I save it to S3 every 5 minutes or whatever, Amazon takes away the machine, I still have all my data in S3. You can also have your data in a EBS storage, which will stay on even though your machine gets turned off. And I'll show you how that works too. So if we look at the on-demand pricing, right, I showed you the $3 for that GPU instance, and then it went down to 92 cents, right? So this is where you can get all those different pricing. So Spot pricing is actually live. It depends on their current load and availability. But what I found is that if you see a price on here, it's generally around that. And so what you do, and I'll show you too, when you launch a Spot instance, is you give it a bid price. So you say, I'm not going to pay any more than this particular limit. So this one, the current price, let's go down a little bit. Let's find our P3. So our P3 here is 92 cents an hour. So I'm going to say I'm not paying anything over $1. If the price goes over $1, Amazon's just going to kill it. So that way you can kind of budget yourself a little bit. So
can I say S3 is only for storage?
S3,
is for computing.
Correct.
Oh.
And S3 is always on all the time. EC2, you have to launch the instance, do stuff, and then you can turn it off.
So when you pay, that's basically pay the computing on EC2.
Yes. S3 you do pay for storage, but it's very minimal, very minimal. You don't have to consider it if you're having like terabytes and terabytes of data, but I probably have like 1 terabyte sitting on my S3, and it charges me every month, and I don't really notice. It's maybe a couple dollars or something like that.
We pay for storage or for transfer of data?
For S3,
Yeah.
you pay for both.
Okay. I
Yes.
didn't see that,
Yeah. So here we can go to S3 pricing actually. Let's do it. Amazon S3 pricing.
I thought it was only transfer.
No, it's transfer and storage. So, so here's the storage pricing, right? So it's like 2 cents per gig. So, and then it kind of goes down, and then down here it'll also show you where's the transfer cost? Somewhere on here there's transfer cost as well. Oh, here, data transfer. So then, see, data transfer in is free. Data transfer out to the internet, that's when you get to around 9 cents per gig if you're doing more than 1 gig. So even if you're playing around with it, Amazon is really helpful too, because they have like a free tier. So if you just want to learn this and try it yourself, you can actually do it for free, and just to see how everything works, see if you like using it, and then you can kind of get going. But then if you see here, out to the internet is 9 cents per gig. But then Amazon S3 these are all of S3's kind of zones where you can launch a machine. So we're going to be operating mostly with the US East, either Ohio or Virginia. That's 1 cent per gig. So you don't really feel it a whole lot when you're going between Amazon services. Okay. All right. So that's EC2. Any more questions on that one? Yep.
So with the spot pricing, like if you're running a job with that and then it takes your thing down, does it start it back up and you have to restart, or do you set up some sort of cron job, or like how does that work?
You kind of have to get creative with it, and really depends on what your workflow is. For what we're going to be doing here, I'll show you, we're essentially going to be doing like a grid search. So at every step, every time I get to a new point and train a new model, we'll save the results to S3. So if the instance dies somewhere in between that, you'd have to relaunch an instance and pick back up where you left off. But doesn't happen intelligently. You kind of have to handle it yourself. So that's the trade-off between the on-demand versus the spot cost. Yep.
So here we use the term Amazon machine images. So images just refer to a bunch of like CPU, GPU, machine.
So the term instance is an actual machine that you launch, and you have this machine to run stuff on. An instance type tells you the configuration. So this instance type is the P3.xlarge that has GPUs, that has 1 CPU, 8 gigs. The Amazon machine images is, if you think about it like taking an image of any kind of computer, is a pre-configured basically it's the software on the machine is a pre-configured image. So let's say I can have machine image that is a Windows image that has TensorFlow pre-installed. So I say, give me a P3.2x large instance, and then use this image to launch it.
Oh, I see.
Yep. So the instance is the hardware, the image is the kind of software. Yep. A few other things to know, and I'm gonna talk about these kind of as we need it. But there is a whole lot of acronyms in the Amazon ecosystem, so you're just gonna have to deal with it. A lot of the times for some of these things is you do it once and then it's set up and then you're good to go from there. You don't have to think about it too much. But there is a lot to consider here because they have to be able to support a whole lot of different type of workflows. So IAM is kind of think how they pronounce it, but that's the access management. So that's how you set up users and roles and policies. Essentially, a user is a person that can log in, launch a machine, do stuff. A role is like a machine-to-machine type permissions. So let's say I have a user, and my user can read and write data to S3, right? That same user can launch machines on EC2. But if I want the EC2 instance to be able to access S3 without the human, you need to add a role to that EC2 instance. So that way, that role has permission to access S3.
Right now, I'm using an instance that the Linux box, and I thought that the person that's paying for it would pay like $600 or $700 a month fixed, and I could have unlimited use of it. Is that an illusion? Is that really?
No, that you can do that. So yeah, you can. The on-demand will stay up as long as you want it to be up. There's also some pricing, like if you really do want it permanently up, you can pay ahead of time. You can pay for 3 months or a year or 3 years or something like that. So and then it would be discounted from the hourly rate.
Does that sound reasonable? $600 a month for a Linux box, it's always there.
It depends on the configuration because they can vary really widely. I don't know off the top of my head, but we can discuss later if you want. So storage I talked about is the EBS volumes. We'll see how that works. It's essentially like you add a hard drive to your instance, right? Your instance comes with CPU, RAM, maybe a GPU, but you need storage there too sometimes to operate with. And there's a whole bunch of networking stuff. So what we're going to do is we're going to open up our box for an SSH tunnel. So we can port 22 to get through on SSH. So that way we can run Jupyter from our computer. So what we're going to do is actually have the browser on our laptop running a Jupyter notebook, but all the computing is actually happening on the EC2 instance. And then key pairs is what lets you log in. So that's the actual authorization for you to log in. And I'm gonna do it right in just a second when we'll walk through the whole thing. One thing I want to introduce here too, and actually this wasn't a thing when I first started my research, which is probably why I ended up using EC2 for a lot of my stuff. But Amazon has this service called SageMaker, and they basically give you the full, anything you wanted to do with machine learning, you can do it with SageMaker. You're going to pay a little bit more, but it's the whole convenience versus having to do things, right? So they have everything you need for building models, for training them, inference, hosting, all that stuff. It's even less configuration than EC2. See all these acronyms I just showed you before? You're going to have to think about all that stuff when you're launching an EC2 instance. If you really just want a Jupyter notebook with a GPU and you want to do stuff with it, SageMaker, it's super, super quick. And I'll show you how to do that. But you're paying for that. So here, I'll show you. Let me just open all these tabs while we're at it. So this is new, and it's kind of, not in that some of it's newer than others, but okay, that didn't help a lot. But what Amazon's really doing is they're trying to put everything that you need to do with machine learning inside of this. And I'm going to be exploring this more for my own work because I think it's really helpful. I'm not, in an industry context, a lot of the times you're not building a brand new algorithm, so you don't need to do some crazy stuff. But they even have an IDE for machine learning, which is actually built on Jupyter Lab, which is Jupyter's kind of answer to RStudio almost. And they have notebooks, you can run experiments, you can tune models, you can do labeling, you can do everything you want. With that, I'm not going to spend too much time on it. But if you look at the pricing, let's look at this pricing. So for building, so what they do is saying building, processing, training, deployment. Essentially, they have this workflow where you can build something on a notebook, and then if you want the machine to be training while you're sleeping, it's a different kind of service. But building, let's go find our P3s again. That P3 now is $4 per hour. And there's no spot option. So the machine by itself was $3 on demand, 92 cents with spot. If you do it with SageMaker, it's $4. So it really just depends on kind of how much budget you have. But we're all poor grad students, right? So that's why I did the spot stuff. You have to write a little bit more code. You have to think about more things, but you do save a lot of money. Yep.
There is nothing you can do with the EC2 that you can do with SageMaker. The only thing is that with EC2 you have to configure it by yourself. That's all.
Yeah, essentially. SageMaker will give you a Jupyter notebook on that machine. So it's the same as launching the EC2 instance, but you just have to configure like a little bit less. So from my perspective, to save $3, I'd rather deal with a little bit more configuration for that. So it just really depends on the context. Yeah. But at work, if they're paying for it, I'm not going to do it, you know? Okay, so that's pretty much it as far as the intro to the cloud Amazon world. The next step is actually going to be launching something. But before I do that, any questions? Any more questions? I need my water.
Can you just say a few quick words about what's in SageMaker in terms of the tools and everything? Is it?
So SageMaker, it's basically just EC2 with some fancy stuff around it. So at the core of it, you're still paying for an EC2 instance, but they basically put software around it for, let's say I have this deep learning like architecture that I want, and it really helps a lot with deep learning, but it needs to train for like 3 weeks. I can tell SageMaker, take this code and train it on this data, and SageMaker will kind of do it for you. It's still running on an EC2 instance, but you didn't have to kind of configure all those pieces. Where it's really, really helpful, I think, is on the serving. So I know I said we're not talking about serving too much, but from the serving perspective, they'll stand up a REST API for you, and you can kind of just hit the API through any sort of app with your trained model. If you did that with EC2, you would have to launch the machine. You'd have to configure the ports properly. You have to configure the load balancing, make sure you have the right size of machine for what's hitting your stuff. So that's kind of the way Amazon does everything, is they abstract stuff away for you and then charge you a little bit more for that convenience. Yeah. And I haven't used it from myself, so I don't know a whole lot about it, but it's definitely something worth looking into. All right. So next up is let's actually use the cloud. So this is kind of a lie. It's not completely zero. I already have an Amazon account that I configured. I hooked my credit card up to it. But you're going to have to do that on your own. But Amazon has amazing documentation. You can usually just search how to do anything. It'll show you how to do everything. So you can do stuff from the command line, or you can do it from the UI. I'm going to start with the UI part, and then our last part of the day, the 4:15 section, I'll show you a lot of the command line or code stuff. But for now, we'll stay on the UI just to learn the concepts. So I'm going to follow these steps. So you see even the difference, right? For launching a notebook to do stuff, these two paths will give you the same exact thing. EC2, you have to deal with a bunch of stuff, configure this, configure that. But once you get it all configured, it's really not hard to do it again. SageMaker, you just say, give me an instance and let me open Jupyter, and it'll take care of it for you. So I'll show you both examples. All right. Cool. So starting with your AWS account. So I'm going to sign in. Hopefully it doesn't show anybody my password. So unfortunately, my Gmail is the same as my regular Amazon account, and so it thinks that it's trying to use that password, but it's not the same password. So all you have to do is go into Amazon AWS, say create. Let me zoom in here. You would create a new account, put your name in, put your credit card in. And again, it's charging per usage. So if you don't do anything, you're not going to get charged. And you can even set up alerts. Like I have alerts like, if my usage goes over $50 this month, send me an email because I accidentally left something on or something like that. So here's your console. So like if you wanted to get to the billing dashboard, you can see it right here. But basically where you're going to be doing stuff is all of these services. And it can be really overwhelming because Amazon has a ton of services. But that's why I just introduced the 3 that we're going to use today, which is EC2, S3, and then SageMaker. So let me get my steps here so I know what I'm doing. So we're going to start with the hard one first because I had to do this, so I'm going to make everybody else feel my pain. So we have an AWS account, check. Next is we need an S3 bucket. So when you go into services, we go to S3 here. Maybe I'll zoom in one more for the people in the back. Again, I am recording this if you want to kind of come back and follow this along. So I have buckets already, but if I wanted to create a new one, I would say create a bucket here. I would have to come up with a name. So this is just like a domain name. It has to be unique. So let's say Aaron's super cool bucket because I've already done Aaron's cool bucket. So that's the name of my bucket now. So anytime I want to grab a file from this, I'm going to say s3:/ Aaron's super cool bucket. And this is all a bunch of options that you can read later. You can read the documentation on. Just to get from 0 to Jupyter Notebook, we're going to leave this alone for now. And this is where you want to deal with those permissions. So by default, your bucket is not open to the public. And probably that's what you want, right? I have public buckets just because I'm kind of doing this teaching stuff. So I'm showing you. But most of the time, you don't want it public. And then that's it. Then you can go, boom, create bucket. You can theoretically make as many buckets as you want. There are limits on your account, but usually if you hit the limit, you just open a ticket with Amazon and say, hey, I need more, and then they'll expand your limit. So now I have this bucket right here. And so if you go in here, you can actually peruse this. It's similar, if you've done web development, similar to like an SFTP interface that you would have like in a cPanel or whatever. So you can upload a file. So see how you can create a folder? Technically, it's not really a folder, but it's the same concept of a folder. So anything inside of that folder would have the specific prefix to its path. But I could upload files here. You can also deal with it on the command line. There are some other GUI tools that you can download on your machine that I'll go through later. But for now, we have a bucket. Okay. Next, we have to deal with a little bit of permissioning because we're doing the EC2 side. If we did the SageMaker side, we would be ready to go ahead and just launch an instance. But I'll show you the hard way first, and then we'll go in the other way. So next, I have to set up a role. So I have my user, right? I have a user, because this is me, a human, logged into the console. There's a user already for me. But when I launch an EC2 instance, and I want that instance to directly be able to go get files from my S3 bucket, I need to create a role. And so we're going to do that. So this is actually IAM. Here, I don't know where specifically it is on this page, but who knows? Somewhere here. But IAM is basically, if you think about all the permissions, that's your permissioning stuff. So I go into here, and so I have users, roles, policies, right? I have users. That's for myself, and that's a lot if you're going to do stuff from the command line from your own computer. I'll show you how to set that up later. But the first thing we want right now is a role. So go into roles, and I already have some roles, but I'll show you examples. So essentially what we're creating is a role for our EC2 to be able to access our S3. So create role. And so you're going to choose the service. So right, the most immediate one is going to be EC2. So you could set roles for all these other services, right? The role is for that. So you're not going to have any users here because this is specifically for the services. So I'm going to say this role is going to apply to EC2. So permissions. So there's all kinds of permissions that you can create for these different roles. But what I care for right now is that I want this EC2 to be able to access my S3. So I can just search for S3. And let me know if I'm going too fast. But so I search for S3 here. So there's a couple different policies. I can say full access to S3, which means I can read, write, delete, and execute anything from S3. Or if you just want your EC2 instance to be able to download data, you can say read only. For our scenario, we're going to want to read and write, so I'm going to do full access. You can also tweak the permissions, and you can say only full access for this folder, quote unquote folder. and then only read access for this thing. But if we're just doing research, it's just ourselves and our own personal account. I'm not going to go crazy with the permissions for now. So now I'll say S3, oops, I didn't mean to do that. I'm going to say S3 full access right there.
So I have a question.
Yep.
So it looked like you named something for this role, like the EC role, and that's, you could have named that almost anything, and then you go in and click whatever service or role you want for that particular access underneath that. So if you wanted to access both S3 and maybe some other database as well, then you could combine those under the roles for that particular instance.
Correct.
That you would make whatever name you wanted to make for that.
Correct. And so you could have even different roles that had different levels of access to the same resource. So you could say, I want this one that only has read access. I want this one that has write access. You can just name it whatever you want. When you launch your EC2 instance, and we're going to go through that, you choose the role that you want to give it.
Okay, thank you.
No problem. So then we go through that. Tags is if you end up doing a whole lot of crazy stuff on Amazon, you can add tags, but I'm not going to worry about that for now. So now here's where we put that role name. So super cool bucket role. So now I have that role. I've already done that before, so this EC2 role is essentially the same thing. So that this role, it's not really just for the super cool bucket, it actually gives me access to all of the S3 within my account. So all of my S3 buckets that I showed you before, if an EC2 instance has this role, it can read write to all of them. So you got to be careful with that. Like if you're giving people your machines to use, they can accidentally delete your data and whatnot. So that's that. So okay, now we're getting to the fun stuff. Now we can actually launch our machine. So we have our account, we have our S3 bucket because we need some place to do kind of offline storage when our machines are not on. And then we have our role to make sure our instance can access that S3. So now we can go to the EC2 right here. And I can say launch instance. So actually there's this new concept, I was playing around with it, and I'm going to use this later, is launch templates. And you see that there's going to be a lot of clicking, so you can actually set up templates for your different types of machines. But I'll launch an instance right now. I'll just do launch instance. And so here is where we start with our images. So it's what software now needs to be on this machine. You can have just a generic Linux. They have Red Hat, they have Ubuntu, they have Windows, they have anything that you need. But what's really nice is there's AWS Marketplace, which is AWS kind of partnered software, but they also have community AMIs. And this is what we're going to use. So AMI is the Amazon machine image. So what I'm going to do, and this is what I've done for myself, every machine that I launch, I'm using a deep learning image. So if you see here, this image comes with Keras, PyTorch, TensorFlow, NVIDIA CUDA, all this stuff. And what it does, and we'll see, it actually creates a bunch of different Jupyter environments. And so you can choose an environment that has this software, an environment with this one. So I prefer the Amazon Linux, which is essentially a fork of CentOS Red Hat. I just like the command line better. But if you like Ubuntu, even if you like Windows, I don't know if there's a deep learning Windows, probably. Oh, there is, look at that. But I'm going to go ahead and go with this Amazon Linux. And you can peruse all the AMIs for any kind of thing you might want to do. And you can install your own software too. It's a computer just like any other server that you might have. So if there's something on here that's not there, you can install it. But the only thing is you have to install it every time you launch the instance. So it's nice to have an AMI that's already pre-built. You can also create your own AMIs. So if there's something that you do that's super specialized, you can create your own and then save it off.
Does it cost anything to save it up?
Nope. Yep. So essentially that I don't believe, I don't know how you would set up an AMI. I've never done it myself, but I know you can just have it sitting around. Yep. So see how there's some free tier stuff if you just want to play around with this. But I don't know, let's go crazy. I'll launch no, the GPU is going to take too long. Let me just launch a C5 instance. So this is the compute optimized instances. I'll do a C5 X large. This gives me 4 CPUs, 8 gigs of RAM. So I'll choose that. If you launched it now, you wouldn't configure all the settings. We need to actually configure a few settings because of the permissions and everything. So we'll do that. So there's a lot of options here, but I'll just kind of run through what you need. So spot is if you wanted to do spot instances, you can see the prices and then you can set your maximum price there. So they don't make it super easy to figure out what the on-demand price is, but the on-demand price for this instance, I would guess, is probably like double these. But if you wanted to play around with the spot, you can. For now, I'm going to do on demand because I don't want them turning off my machine. A VPC is essentially the network that you have. VPC stands for Virtual Private Cloud. You can look at that a little bit more yourself. I'm not going to go into that right now just for the time's sake. We can talk about it more later if we have time. So, I believe, do we need subnet? No, we don't need subnet. So, auto-assign public IP. That's important for what we're doing because you need a public IP address because you're going to want to SSH onto this machine from your computer. So, I think I'm doing this right, but I'll just go. Oh, subnet setting is enabled. So, you want to make sure you have a public IP because you have to get to it. I don't know what this stuff means. And now here's our role. So now you can put your role and say, this is the role that my machine now has this specific role, and whatever you set up that role to have, now it has it. If you wanted to from the screen, you could actually create a new role. So you could just start from here. Shutdown behavior is interesting. So shutdown behavior is if you do like a sudo shutdown now, this is going to decide what it does. So terminate means delete my instance forever. The storage disappears. I can't get that instance back. What stop does is it actually turns off the machine. It takes away the machine. You're not paying EC2 cost anymore, but it keeps essentially your hard drive around, which is your EBS storage. And that's pennies on the dollar as well, similar to S3. So what you could do is you launch a machine, and then when your shutdown behavior is stop, it keeps the hard drives just sitting around. So if tomorrow, you're working today, I'm done, I'm going to turn it off, I'm going to stop it. Tomorrow I can come back in, launch an instance, and it's going to reattach those hard drives right back to it. So if you have terabytes of data in those hard drives, it's going to be expensive. But if you just have a couple notebooks on there or whatever, it's really easy to pick back up where you left off. So that's actually what I'm going to do today. I launched a machine yesterday, I stopped it, and then today I'm going to pick it back up for what we're doing later. But if you don't need the storage, you can set terminate, just up to you. And besides that, it's a bunch of options that I don't need to go through right now. And then here's the actual amount of storage. So you can decide how much storage you need, and you actually pay per gig. So for now, 90 gigs is going to be plenty. But if you have some big giant file that you need a lot of storage, you can make that bigger. And I think, next, so we don't need tags. But the really important thing that we're going to need next is because we want to do Jupyter with this, is we need to open up port 22 for SSH. So by default, any machine that you launch from Amazon is completely firewalled off, right? Because you won't want just random people coming onto your machine. So a security group, similar to like a role or something, allows you to set up a template of what's my networking security for this machine. So for what we're doing, I already have a security group, but you could create a new one. I'll select an existing one, which is right here. And essentially what I have in this security group is I'm allowing port 22 from anywhere. And I'm also allowing port 6006. So port 22 is for SSH, because that's the main thing that we're going to need so we can get onto our machine from our laptop. The 6006 is for TensorBoard. So if you've done TensorFlow, you know what TensorBoard is. I won't really explain that. But all you need really is this port 22. So you can see here is open ports and security group, SSH 22. So you could create a new one. You could say SSH, my port range is 22.0.0.0.0, add my rule. So boom. I'm going to click my existing one because I'm afraid I'm going to mess something up. So most of the time, if you're just doing this Jupyter thing, port 22. Now I can say launch. My machine is launching. So see, my security group is open to the world. It's warning me because technically anybody in the world can get through port 22. You can't actually SSH onto it unless you have this key pair. So sorry, I just clicked that launch button. And so the key pair is really your main thing, which gives you access from anywhere in the world to log into your machine. So this is just regular SSH stuff. So I'm going to choose my existing key pair. And you have to have that PEM file. If you create a new key pair, once you give it a name, you download that PEM file, and now you have that file. That's your keys to get onto your machine. So you don't want to lose that file. If you lose it, you can make a new one, so it's not a big deal, but you definitely don't want to give that to anybody. And you definitely don't want to commit it to your Git repo. Not speaking from experience. So I already have a key pair. I already have it on my computer. We're good to go. So now I launch my instance. It usually only takes a couple minutes at most for the instance to launch. So I can click here, or what you can do is I can go to my dashboard. I think you just click here, EC2. Now it kind of gives me information. So usually I wake up with like hot sweats in the middle of the night and I log onto my console and I'm like, oh my gosh, did I leave an instance on? So you can come here and just make sure. So that's something to remember is if you leave it on, you're paying for it. So sometimes if you want to, what I do in my code is I set up code for an experiment and I say when it's done, shut down. So that way I don't worry about running it. But I've definitely spent $50, $100 on machines that I accidentally left on. So just be careful with that. So we have our running instances. Right now it's running. We can see there's the stopped one that I have, which is the one that I created yesterday with a much bigger machine. I'm going to launch that back up during our break because that's what I'm going to do the rest of the tutorial with. But this is our C5 X large that we created. If I click it here, here's some of more information about it. All we need right now is I need my DNS name or your IP, but DNS name's easier to read. That's how I'm going to get to my machine. So if I'm hosting a web service, with port 8000 or something, I would use that DNS name to get to my machine now. For our cases, we're going to go through port 22, so I'm just going to use that for the SSH. So I have some code here for us to do that. So let me just show you. First, let me just copy this. I'm going to copy the clipboard. I'm going to open up a terminal. And I'm going to zoom in a bunch. This resolution is horrible. Okay, so SSH. Then I'm going to point to my key file. So that's just -I. I have my PEM file here already. And every time you launch one of these machines, you're going to use EC2 user. I believe that's only for the Linux AMIs. If you use Ubuntu, it might be a different user. If you use Windows, it might be a different user. But right now it's EC2 user at DNS name. So that thing that I just copied. This command now is using my PEM file. Those are my keys. EC2 user is just the user that you have to get onto the machine. If you created other users on the machine, you might be able to log in with those too. I haven't played around with that. And then you get your DNS name. So boom. So you make sure you're not a hacker.
So EC2-user is always kind of like the prefix username for every domain name?
Yeah, essentially. Unless you specifically configure it to not be that, most of the time that's going to be it. So now I'm on a machine. So it gives you some boilerplate stuff. Like here's how you can activate all these different environments. We're not going to do that right now. What we're going to do, what I want to show you is if I do top, right? I think if I do top-M, we can see that my machine now has memory 7 gigs of RAM. So I don't remember exactly what our instance type was, but now you can see the resources that you have. Just a neat little trick if anybody's doing stuff. I like to install this package called htap. It's just a little bit nicer. Sorry, let me show that command again. It was just sudo yum install htap, but essentially it's just like a prettier top. So now you can see really the resource utilization on all your CPUs. You can see your memory utilization. You can see all your processes. That's just a Linux thing, but I like it. We're going to use it later on after the break to show you how I'm actually using my resources. But now we're on our machine. So that we are on an instance in the cloud. But if I want to launch Jupyter, that's very different because Jupyter is a web browser, right? So if I launch this web browser from here, there's no GUI attached with this machine. So what I'm going to do is do an SSH tunnel. So essentially what that means is I'm going to forward a specific port from my EC2 instance onto my laptop. I'm not opening it to the world, I'm just opening it to my laptop. So that way I can go to localhost, whatever port, then I'll get to that browser. So I'm going to leave this SSH, and I'm going to copy this command because it's a bit of typing. So here, so I got to put my PEM in there. So what this -L does is says, take port 8000, forward it to my localhost port 8000. If you have a Jupyter running on your laptop, you might have to change this port to something else because it's going to conflict. But now I put my host here. Let me grab my host name again. And same thing, it's just an SSH, just like any other SSH, hopefully.
This is to basically have a tunnel from, like, because you don't have a GUI up on this particular Linux.
Exactly. So what this is doing is it's forwarding my web tunnel from the EC2 instance to my laptop. So now my laptop, port 8000, is actually opened up to my EC2 instance, port 8000.
So can you do that on the web page through clicks on links?
I don't know.
Or
I don't
you
know.
have to do that through the command.
If you're going to do it like this, you have to do it like this. But I'll show you the SageMaker, which is going to be a little easier.
Can you bring up that command just?
Yeah, of course.
I was going to say, can we check whether we can capture the screen?
Oh, I'm capturing the screen also on my laptop. So I'm going to edit them together, and then the video will have both. And I'll share the slides too.
And it's going to be on your Twitter.
Yeah, or email, or maybe we can get in the conference to send it out. So we'll see. So these next two commands is what you're going to run to actually get your Jupyter Notebook running.
I don't know, we will put it on the conference website.
Okay, we'll put it on the conference website. There you go. Much easier. I mean, you can still follow me on Twitter if you want. I get more followers. So what you're going to do is you're going to launch Screen, and then you're going to run a Jupyter Notebook. So if you're not familiar with Linux, what Screen is essentially it runs essentially a process that's running all the time. So for instance, if I were to launch Jupyter right now, and then if I close my laptop, that kills my connection, it would kill that command. But what Screen does is it says run it behind the scenes and run it all the time. So just, if you don't really know, just follow what I'm saying and it'll work. Screen-L means save a log file somewhere. So now I'm inside of a screen, and now I run this Jupyter Notebook command. So what's going to happen when you're inside this screen, if you're not really familiar with Linux, is you're not going to know how to get out. So if you press Control-A, and then you press D, means disconnect. And now I'm now back to the main place, but my screen is still running in the background. So if I do screen-ls, it's going to show me my screens that I have attached, and then screen-r will reconnect. If you have a bunch of screens running, you'll have to type the name, but if you only have one, R will reconnect right back in. So if you see me jump in and out, that's what I'm doing. So now we have our Jupyter command. We're going to say run it with no browser because the dashes get messed up from the keynote. So -- no browser, because obviously there is no browser on this machine, but I'm saying port 8000. So this will probably take a second. Sometimes it takes a second for this stuff to warm up. So we'll let that run for just a minute. Any questions while this is happening?
Sorry, I didn't get that. So you said we were kind of like port forwarding the server port 8000 to our laptop to kind of like simulate running like a Jupyter locally on it?
Yeah, so essentially what it is because we want to keep our EC2 instance blocked off from anybody else, technically I could, in my security group, open up port 8000, and then anybody in the world could get to my Jupyter, which is not the best. So what the port forwarding does, it says only my laptop can get to that port. Yeah. So it's just saying mirror my port 8000 to this port 8000. I could say mirror my port 123 to the other port 8000.
Perhaps you will speak about it, about Air after, but there is the equivalent with Air, with Air web server. Can we install it very easily on EC2 or?
Yep, you can install anything that you need to, especially if it's installed via Yum or apt-get, or you can even build your own stuff. It's a machine just like any other machine, so you can do everything that you want to.
What about Docker, right? So if you wanted to run like Docker containers quickly on there, so you could almost have your own environment, almost like your own AMI or whatever that has your Ubuntu and whatever else is installed. Can you just put that quickly onto one of these things that have a Docker container that you can run it and
Yeah, and they actually make that really easy. I haven't done it myself, but I know Amazon has a lot of stuff there around Docker, but you could just have a Docker image. If there is no AMI that exists and you don't want to do an AMI and you need to use the Docker maybe on your own on-prem servers and you want that same environment, you can just take it, pop it in here, and it'll work just fine.
When you configure your machine, can you pick different versions of like Python, like TensorFlow?
Yep. So actually, what we're gonna see here is it comes pre-configured with all of these environments. So there's TensorFlow with Python 3, there's TensorFlow with Python 2, there's Theano, CAF, base Python, like all of these environments. So I'll show you now that our Jupyter is running now. So to get to the Jupyter, you have to copy this command. So because I forwarded port 8000 directly to port 8000, this URL is going to work. But if I forwarded to a different port, when I get to my computer, I'd have to type in that different port number. But that's pretty straightforward. So now I have this command, or I have this URL, and we can see now, boom, I'm on Jupyter. So this is now Jupyter running on my EC2 instance. So if I go to create a new notebook, you see how there's all these environments that are already pre-configured. So most of the time on your laptop, you're just going to see Python 2, Python 3. But this AMI already came pre-configured with all of these Anaconda environments. So I'll use the TensorFlow one a lot, just because that's me, or just the Conda Python 3. The Conda base has everything you need in it too. It has SciPy, NumPy, scikit-learn, everything. So unless you're actually doing deep learning, you could probably just do this Python 3 one. So I
also do the content update by itself.
Yeah, and so all of these are in individual environments. I didn't like that for some reason.
They're under your control.
Yep, it's just on this machine. So if I wanted to go, like if I did like a pip install whatever I wanted, that would only be in this environment and in this computer.
All
So
those are the same image, right? Because you already had, you spun up an instance and then you put an image which had, Python 3 on it, but you're saying that Python 3 already has multiple different, within that image, multiple different other environments, like virtual environments,
yes.
environments in there that you can then select, within that.
Yep, exactly. And you can modify them as much as you want. Yep. And we're actually going to do that because later on after the break, the scikit-learn version, the latest one, doesn't work with one of my things, so we have to uninstall it and install a new one. But now we're in Jupyter, so I can just import pandas. Boom. And when you first launch it from the very beginning, it takes a second to warm up, but after this, it'll be really quick and snappy. So let's see. So now this is Jupyter just like normal. What we'll do, I can take a couple questions now, but then what we'll do, we'll take a break now. And then after the break, I'll run through some Jupyter examples from one of these machines, and then we'll get into the R code in a bit. Any more questions before we break?
So you have a code already, and you want to start running it here on social media.
So you can, and actually you can do this, and I was going to do this later, is you can upload your notebook. Or you can clone a Git repo. So if you go back into here, and I'm doing the Control A to disconnect, I can just do git clone of whatever I want to grab my code. That's usually what I do. Oh, yes, SageMaker. Thank you. I forgot. So SageMaker is really easy. So before we break, it's going to take like 2 seconds. So that's the hard way, right? If you go into SageMaker and you're just like oozing with money and you want to use that one, you can go in here. We'll find SageMaker. And you create notebook instance. I guess you have to give it a name. All right. I've actually never really done this. And then you click your instance type. So let's do the C5 again. And then that's it. It already has a SageMaker role and IAM role. See, and it has permissions already for S3. We didn't have to create our own IAM role. And then you create notebook. Actually, I think I had to do networking, but we'll see. So once this launches, actually you're going to be able to go into here, and you'll just be able to click Jupyter Notebook, and it'll take you straight to the Jupyter.
Do you always need
Right
to
here.
have an S3 account, like this, to save data on there? Can you just have an instance and then upload directly data to that instance?
Technically, yes. Like if you want to do an SCP or something, or if you had it hosted on some other cloud or your own website, technically you could. I think you might still just need an S3 bucket because maybe Amazon does some weird things in behind the scenes, but you don't have to have S3. It's much faster and easier to kind of do stuff, but technically you don't.
It's probably cheaper too for S3 because your storage costs can get more expensive with the other storage options.
Yep.
It seems like a big benefit would be, especially if you're doing, that you can constantly save to it, right?
Yes.
So save off, so if your instance disappears or you want to shut it down.
Exactly, and then your storage is always there. And so it takes the same amount of time. It's still launching, but eventually once this launches, we could just click Open Jupyter, and then it would work. Yep.
So SageMaker, you made a whole bunch of explicit choices about read, write, execute, delete, about ports that were open and so on. You just did that with one click in SageMaker, so it's a set of
Yeah.
default profiles that they have that you have to read and understand what that is, and then you modify those if you wanna change them?
You could modify if you wanted to, but yeah, so actually with SageMaker too, you don't have to do the SSH tunnel because
Right.
it hooks you into the whatever the Jupyter already, and then I guess it authenticates through your Amazon account, so that way only you can get to it. But then it's really the cost consideration. So if it's not a problem to do that, then it's good. And the reason I'm showing the EC2 also is because this was kind of before SageMaker was around, and it kind of helps to know because SageMaker is just a wrapper around the EC2. So if you launch it and you don't know anything else that's going on, sometimes it's hard to debug if something's going wrong.
True.
Yeah.
So this is basically the three kind of extra dollars you pay per hour
Right.
to get this kind of easy setup.
Correct. And so here we go. Here it is. Now I can click open Jupyter and it takes me right to my Jupyter. I didn't have to open a tunnel. I didn't have to do anything. And so I guess it makes some special URL for me. And then I think it has environments also. Oops.
So you could then make a Jupyter
Yeah.
offline, like on your own laptop, spin up this thing, right away, and then say, okay, well, I'm gonna upload my Jupyter notebook to my laptop, so I'm not wasting time, coding an architecture or anything, developing the code, and then run it, just so that it's running the training basically on the.
Exactly. And that's actually what I do. So what I'll do is I'll get a small chunk of my data. I'll sample my data, put it on my laptop, do all the development there. Exactly that. Just upload the notebook. Now I just have to run it and wait longer and debug it, of course, because you're not going to get all the edge cases on the sample. But yeah, that's exactly right. So you don't have to spend all of your money when this is up like this.
How do you stop the instances?
So there's two ways. So actually, I'll show you. So here, you can just stop it right here. I'm going to go ahead and do that because I don't want this up anymore. And then inside of EC2, you can go into EC2 and go into your running instances, and then I can click this checkbox and instance state. So actions, instance state, stop or terminate. So remember I explained what the differences between those are. Stop will leave the storage up, terminate will delete it completely. One other way, which I find a lot easier because I'm already SSH'd onto the machine, is I'll just shut down from here. So if you just do a shutdown command, and this is perfect because this will lead right into our break. If I do sudo shutdown now, boom, shuts off. And now it's stopped. If I go back to here, probably take a second. Let's refresh. It'll shut down, I promise.
Just charge for those extra few seconds.
Yeah, exactly. But then, there you go. Now it's stopped. So then, boom. And if I wanted to restart it, I can just go back in here, and I can just launch. I think launch. Yeah, no, I would go back into this, instance state, start. So if I restarted this, my Jupyter would just come back just like it is. It's going to have a different DNS name because it's actually a different box. But it finds wherever that hard drive was and hooks it back up. So my state of my machine will be exactly the same, but it's actually technically a different machine.
It's not the same DNS each time.
Different DNS each time. Yeah, it'll be the same hard drives. So all your stuff in it will be the same, but it'll be a different DNS. Yep.
How do I share my EC2 instances with others?
You would probably want to create different key files for everybody and then attach them or something like that. There's a whole bunch of permissions, users, groups, and all that stuff that you can do. What you could do is just hand the airdrop or whatever your PEM file to somebody else, and then they could log right in. It's not best practice, but you could do that.
So do you have to redo the SSH tunnel then? So when
Yes.
you bring it up?
Yes. So if I were to start this again, I would have to run this SSH command again. But what I do is I just create some sort of thing in my bash profile to do it real quickly. You can create a little function for yourself.
You do have the elastic IP, so you can retain the DNS if you really wanted to. Elastic IP.
Yeah. Okay. Yes, that's true. You can if you really wanted to. I don't know. I'm not familiar with how to do that, but it's definitely possible. Because of course you think about if a company has some sort of server running behind a machine that they have all the time, they would want that DNS to be exactly the same. But you
The
could.
distinctions between using a Jupyter notebook and using a Docker container is that the Docker container lets you do the setup so you can pick your particular versions of TensorFlow and scikit-learn and all the particular things that you need to run your code, whereas you have some control over that on SageMaker, but they kind of lump it all together, it seems like.
Yeah, SageMaker kind of pre-configures it and has all your stuff. It's essentially like an AMI, which an AMI, if you think about it, is pretty much the same as a Docker container. It's a pre-configured image. A Docker, you could take it now, install it in some other place within that Amazon. So you could technically have like 2 different Dockers on the same instance. But that's a whole different thing. That's just up to however you want to configure all of your environments. Technically, Conda environments are also similar to Docker in that sense, where you could have multiple different Python environments on your machine that have different purposes.
I found the price bidding a little bit annoying because if right now you enter the highest price, but over time there's a possibility that your job can be kicked out of the queue because of bidding.
Yeah, so spot is a little bit weird. So actually what I normally do with a spot price is I set the bid price to be exactly the same as the on-demand price. So if your on-demand price is $3, the current bidding price is 90 cents. I'll just set my maximum bid to $3 because it's never going to go over that. But when you get the machine, you're only paying the spot price. So that spot could fluctuate from 90 cents to $3, but you're going to pay it. But you're always going to have a risk of, even if you're above the bid price, there's still a risk that Amazon's going to shut it down. So it's really just this kind of game that you're playing. Yeah. Actually, SageMaker has this thing, and I have a link in the slide deck, is not for the building part, but for the training part. You can actually launch a pool of spot instances, and SageMaker will handle spinning them up and down if they get killed. So then you're only paying spot prices, and then but then you have to pay for SageMaker. So but it's all just a game. You kind of have to figure out what's your best workflow. What I ended up doing for my research most of the time was I used spots, and I just checkpointed all the time to S3. And then I was fine with that. It would get annoying sometimes when I had something running for 5 days and then it terminates and then I have to pick it back up where it left off. But if you like to code and you like to build that stuff, you can build some stuff around it, or you just pay the on-demand.
What was the frequency with which you saw that it logged you off?
It actually got worse this year. Like 2 years ago, I usually never had a problem with a spot disappearing. And then, of course, right when I was trying to finish my PhD and do my last experiments, all of a sudden these spots just kept dying everywhere. And I just switched to on-demand because I'm like, all right, I'll pay the extra money. I just want to graduate. But it's changed. They changed something this year to where the spots are less reliable. So I haven't used it too much myself in the last few months. But you kind of...
Last a week usually?
No. You could last a day if you're lucky.
Okay.
Yeah.
Check it every day.
Yeah. So I a year ago I got some for like 3 days a week, but this year when I've been playing with it, I was lucky if I got like 3 days out of it. So it just depends on what you're doing. So for what I did, I'm sorry, I'll get to your question in just a second. What I was doing is, for my experiments, I was doing a lot of small models. I was doing like hundreds and hundreds of models. So in that case, if my machine's only around for an hour, it was no problem. But if you're doing some big, long, deep learning model that trains for a week, you're going to have some issues. Yep.
And if you're working with the spot, then you can use SageMaker to have it restart the spots.
I don't know. Actually, I have a link on my slides here. So not for building. So what they call building is your interactive notebook environment. This spot thing is for training. So you would already have to have your code ready and your model ready. Maybe you build it on an on-demand, and then it'll use spot for the training. So if you have a long-running deep learning model, it'll figure out how to relaunch those. But then you would pay spot prices. Especially when it comes to GPUs, spot prices are really nice. Yep.
Do you know why they're doing it this way? This is all based on units, right? So you could just do a nice minus 20, put a thing in the background, maybe it pauses for 9 hours when Amazon's at peak and it picks up by itself. They're saving the instance for you anyway.
Yeah, I don't know.
Why would they put you through all the manual exercise and not just allow you to lower your system priority?
So that way you pay on demand. I don't know. That's Amazon's choice. I don't know how the other clouds do it, but that's just kind of how when you're working in this environment. So I'm not sure a lot of the history on that. Yep.
When your machine is stopped with the spot, does it save a hibernation file?
Yes. So it saves essentially your hard drive. So it's your EBS. Where's my console? So if you see this spot, spot here is stopped. If I go to my Elastic Block Store volumes, we see that I actually still have 2 volumes. So you're paying way, way, way less than EC2 costs. It's pennies on the dollar for this one. But if I were to go back into this instance, relaunch it, it'll hook right back up to the EBS. So my whole hard drive is there. All my notebooks, whatever data I have on that hard drive is still back. If you terminate, that's when it kills the EBS. But starting, you get it back and forth. All right, so it's 2:30, so this is the break time for the rest of the sessions. We'll come back in 15 minutes and then dive into some machine learning. So 2:45, we'll start up again.